So hi everyone, my name is Tsahi Levent-Levi, Logic Me, Test RTC. I do a lot of weird things around and with WebRTC. Nice to see you all here and joining, and let's start. So I want to talk about scaling WebRTC, and I want to start with a question. And scaling WebRTC has changed a lot or a bit, and that's because of a pandemic and the fact that some of us are quarantined at home, some of us have kids at home. The world is, in a total mess. And the question is, how did the pandemic change your life? Okay, think about it. What are the things in your life that have changed so far because of what's going on? If I'm looking at what happened to me in my life, not much has changed. I've been working from home earlier. I've used video conferencing. I'm in this industry for the last 20-something years. But when I look at the world around me, or let's say at my family, there are a lot of stories around that. And I want to take 3 personal stories of 3 generations in my family. I'll start with my son. This is where he's sitting today. He didn't have this place at home up until now because there was no machine there, no desktop, no nothing. It was just all the garbage was there. The pandemic started, we quarantined, and we've started putting things there for him to be able to sit and learn. And then at some point we said, well, he's got a problem in Hebrew. He's not, doesn't write that well in Hebrew. That's because he's not reading enough. Huge problem. What do we do? We find a private tutor for that. So we went and searched for someone. We found someone. She wasn't from around the area, but we didn't care. We simply asked him and told him, Amit, do you want a tutor to teach you over video? He said, okay. And now he has a tutor that teaches him over a video call all the time. Even with the pandemic going over, coming back, nobody cares. She's teaching him remotely. We don't even think about bringing him to her place or her to our place to do this training or teaching session because it works so well. Let's move to my wife. My wife is a Pilates teacher and salsa dance teacher. She's doing private lessons, group lessons. Pandemic starts, no one comes. There is nothing you can teach in these days around these areas because this requires being in the room with that person. So she starts by taking my laptop. This was at one point in time my laptop, no longer true. And then she took my webcam, so I need to buy a new webcam for me. Then we needed to buy a remote, a wireless microphone with a lavalier for her, and then another microphone, a headless one. And she's like becoming all technical. She didn't touch anything before then. Today she schedules the calls, doing them, and making revenue. The interesting thing, though, is that one of the things that she started doing is to do recorded lessons. So she records herself doing these Pilates lessons, and then she sells that online, for months of activities, and that goes alongside the group sessions that she does. And she's going to continue that after the pandemic as well. So this has opened something new in her life, something new that she's doing. The third one is my mother. I've decided to take this picture because this is what I have behind me here. She's painting, and every few months she brings a new painting to my home and replaces the previous one with a new one. Now, my mother started doing Zoom calls. So she is now joining different sessions of people that talk online. She's got once a day at 5 p.m. every day a reading of a book with a group. They just sit there and read the book together. She comes in here one day about 2 months ago and she says, I want to be a Zoom host. How do I become a Zoom host? Now she's 71 today, so she has a birthday. And why the hell would she want to be a Zoom host? For what purpose? She didn't have the answer for that, but she knew that this is something she wants to do. Okay, so people are changing and the world is changing around us, and we need to understand that. Where did all that lead me to? All of these, stories and tidbits. I'm sure that you've got stories of your own around the same vicinity and area of expertise. First of all, we now have over 1 billion people that have been indoctrinated in doing video calling. It's not something new to them. We don't need to tell them, this is how we do video call. You go here, you go there, there's a camera, there's a microphone. They already know that. Someone taught them that. My kids are doing video calls all day long alone, for school, with friends, whatever. They don't need anyone to tell them or instruct them what to do. And the second thing is that there is no going back to the old normal. Whatever was the case a year ago is not going to come back. Not today, not tomorrow, not 2 years from now, but there is no new normal yet. Okay, it's not as if what we see today is what's going to stay a year or two from now either. So we're in a transition period, a very fast transition period. And what does that mean in terms of scaling? What do I see when people come to me and ask for things that relate to scale when it comes to my work in the domain of WebRTC? So the first thing is, they want to support more meetings on their service. Someone comes in and says, my service grew 10 times. I needed to grow the number of servers that I had within a night. How do I do that? How do I deal with such growth? The second type of scale is, I want to have more people in my meeting. Okay? Up until now, you needed calls of one-on-one, 4 people, 8 people, that was great. Today we're talking about 50, 100, 200, 1,000 people in a single session. They might not be all speaking, they might be all speaking, we might need to show them all, some of them, I don't know. But the need, the actual requirement to have more people in a meeting is there and it is growing. So it is, it is normal to see meetings with 20 people today. It makes sense, especially in classes. The third dimension that we have for scaling is the scaling of geographies. I want to penetrate new geographies. My service runs in the US, we want to move to Europe. My service runs in Europe, we want to move to Asia, whatever it is. Okay, we want it to run everywhere. How do we deal with that? What do we do with such a thing? So let's start with, I want to support more meetings in my service, and in a way this will segue towards the geographies as well. Let's start by splitting the work we have to do. If we're talking about WebRTC, we've got a few servers that we need to think about. There's signaling. That's how I'm sending the fact that we need to do a session, me and you. Then there's the application logic. Okay, these are 2 types of servers that are there. They might be the same server encapsulated together with signaling, or they might be totally separated. And then there's turn servers, turn and stun for doing NAT reversal. We need that in order to be able to reach people with our media. And then there are media servers. We like to record the call, we want to do a large group call. For these things, we need a media server. Okay? Now, why am I splitting the work here? The first thing is because there are different requirements for different types of servers. If I'm looking at the application logic and signaling, and I'm thinking about latency, then if they reply after 1 second, that's still fine. It's not that big of a deal if I do something and it takes it a second to happen. But if the turn server or the media server will take a second to complete a thing that they need to do, then it's just too much. Okay? So in our case, what we want there is something to go below 100 milliseconds if possible in terms of latency. We like to lower the latency as much as possible. I see that someone wants the mic. Let's see if we can accept him for a second and see what he has to say.
Hi.
Hello.
Good. It's evening. Yeah, it's 6:10 p.m. here, so I don't even actually know what. So, thank you. The session has been interesting. Actually, what I want to say is I don't even know about a plugin that is built on WebRTC and for Flutter. I don't know if you had if Agora is actually the author.
Yes, this session is about scaling. Okay, it's not about plugins, and so this is for another session probably. Sorry.
All right.
Okay, so let's continue. I'll keep the time in the end for these questions. Okay. So we're going to split this into 2 parts, signaling and media. Media requires different types of servers and signaling, and we need to think about them separately. What does that mean? It means that if I want to be as close as possible to the user, and I need to do that if I want to scale a meeting and if I want to scale a service geographically, I need to think about taking the media servers and putting them as close as possible to the user. The signaling servers can be a bit farther away, I don't care, but the media need to be as close as possible. How do you do that today? We use cloud servers. If I'm going to use Amazon, for example, to think about distances and being as close as possible, then Amazon has 24 launch regions that they have launched. This is from, I think, Q2 this year. I go to Amazon, to Google Cloud, there are 23 regions and a few more that are just opening up. If I go to Azure, there are 60 plus regions, which is great. But if I need a region or a location that is not where these cloud services are, it's not going to be good for me or my service. Okay? If I'm going to put my machines in US East, because that's where everyone puts their machines, I'm not going to be able to serve people in Europe properly for video calling. So I will need to spread my servers as well. So bear these things in mind. Okay? Now, if you look at these data centers and you say, okay, let's pick them, then we need to also talk about costs. Okay? If you look at the bandwidth and compute costs of different cloud vendors, like Amazon, Google, and Microsoft, they are expensive. If I go to tier 2s like DigitalOcean, prices go down. If I'll go to wholesale data centers instead, that aren't even hyperscale data centers, the price will go down more. So why am I not here all the time on the wholesale side? Well, that's because of other things that I'm looking for. If I'm looking at tier 1 cloud vendors, what you'll see there is that they offer a lot of different services, not only compute and network. Okay? And I want to use these services. Each icon here is from the AWS cloud, and I'm going to use things in machine learning, network and delivery, a bit of storage, some media services, maybe developer tools or whatever. Okay, so there are a lot of things that I might need, and each icon here is a bunch of different services. So there is a lot that I want and need to use, and I want and need to use them because I want velocity for my developers. I want them to be able to develop fast and scale fast what they're doing. Okay? And that's a problem because on one hand, the price points for these cloud vendors is very high and restrictive. On the other hand, the velocity and hypergrowth that I can get from them is really, really good. And if I look at wholesale, it's the exact opposite. Okay? Now, when we talk on footprint, it's a bit different and nuanced. With the cloud vendors, I can reach a lot of domains. But if I go to wholesale, it means that I'm working not with one wholesaler vendor, but with a few. And I need to be able to work with my software on multiple such data centers that don't look the same. Okay, so I can get a bigger footprint, but I need to sweat it, to work harder to get there. What I don't get here at all is the velocity and the hypergrowth that I need from the cloud. Most vendors, what they will happen to do, or most developers, will decide to try and mix and match. They will run the signaling in a dedicated cloud service like Google, Amazon, or Azure, and then go and use whatever services they have. But they would try to build the media stack that they have, all of the media servers and the turn servers, in a way that they can shift them and move them from one cloud vendor to another or to other wholesale vendors altogether. Okay? And this is one of the things why when I'm thinking of scaling in WebRTC, I'm trying to split the servers into their different types and think of the scaling of each server group separately. Now, if I want to support more geographies, it's easy. I'm going to use more data centers because if I'm using only US East as a media server, this isn't going to bide well for a call that is done in India. It needs to go all the way to the US and back for each packet that is on that call. So what do? We go for the fact that let's allocate a server for that call, for that group call. So I'm going to allocate a server by the first one that joins the room. If he's joining from India, the server will be in India. But then if all the other people or participants are joining from elsewhere, we're again screwed with something that doesn't match what we need. There is no good matching algorithm here, okay, that will work, nothing. And the way to do that would be to go to a technique called cascading, where I'm going to use multiple servers, multiple media servers, and they are going to communicate with each other and share the media between them. And only the edges or the devices will connect to the closest media servers in their region. Okay? Now let's go to the most interesting part, which is how do we get more people in my meeting? That's what people are trying to achieve today, especially getting to the Zoom 49 gallery view, but also to other things that they need. Getting WebRTC to go above 10 or 20 is tricky, and you need to sweat for that. Doesn't matter if you use CPaaS or something else. It's always hard to get there. And when you think about optimizing the meeting size, you need to think about different layers. We're going to take an onion and peel it layer by layer to get and optimize each and every one of these layers. So we can start from signaling, move from there to the transport, then deal with the codecs, and then deal with media processing. What I want to show now and share are some of the techniques that are available there, some of them in the domain of signaling, and some of them in the domain of media processing and codecs. Okay, let's start with signaling. Before we do, one more thing. This is a simple slide, but it's not that simple. The bigger the group size that we have, the higher the complexity is going to be for us to build it. The fact that we can do one-on-one means nothing for us to be able to do 10. With 10 participants, we need to use different tools. We need to move from peer-to-peer to an SFU model or an MCU model. Okay? If we're going to 100 people, that's a different story than doing 10. Even 50 is different than doing 10. Doing 1,000 and more, likewise. Going to 10,000 or 100,000, again, different techniques and tools that we are going to use. What I want to show here are some of the techniques to get you to 50 or 100. And we're going to use the SFU model. In the SFU model selective forwarding unit, what we have is a media server. The media server can be cloud distributed, single machine, doesn't really matter. But in this case, every participant sends his own media towards the server and receives media from all the other participants. Might not be all of them. The server can selectively decide what to send to whom, but this is like the classic representation of an SFU. Now, if you look at the peer connection in WebRTC, and you take a log of the messages, this one is from UpRTC, just an example that I took for this purpose. Look at the messages, the calls. I try to pick and choose out of the API calls which API calls are actually going towards a message that sits on the network. Okay? These are the messages. So set local description goes to the network. On ICE candidate, something came from the network. Add ICE candidate, sent over network. Set remote description, something was sent or received from the network. And if you go and count, you'll see that there are 10 plus signaling messages that are being passed, something like 12 ICE candidate pairs that are being exchanged for UpRTC. That's with a single STAN server, single UDP, and single TCP for turn, no turn TLS, and no IPv6 candidates that were exchanged. This means that I've got tens of messages for one peer connection. Okay, why am I saying that? Some of the solutions out there will say, well, we've got this. Each such line is going to be a peer connection. So in this case, we create 5 peer connections. If I need to create all of these peer connections at the beginning of the call, that's going to be hard. If we have 50 people and the 50 person joins, he is going to open 50 peer connections in parallel. That's going to be hundreds and hundreds of messages that go over the network for signaling. I guarantee you that some of them are going to fail. So I either need to start staggering how these connections are created for my new user that is joining, or I need to switch to a unified plan approach with a single peer connection for everyone. Okay? So we're now starting to look at the types of technologies that need to be there when we need to scale a single session. We use simulcast in large group calls. In simulcast, the client is going to send multiple bit streams. in different bit rates and resolutions, okay, to the SFU. And the SFU will pick and choose what to send to the client on the other side based on different things, like what bitrate is available, what device type, what is the size of the screen, what is the layout currently. If I see the person in a small box, I will send the 150 kilobits one and not the others. So these are tools that we now have and we should start using. Now with simulcast, we can do one more thing, especially if you're using VP8, and that's to use temporal scalability. And let's understand what's that first by looking at encoded video frames. Okay, in a video codec, I've got an iframe. That's a frame that is full. It's like sending a JPEG message. And then the next frame is a P frame. And it is reliant on the previous frame that was there. I'm going to encode only the differences between the previous frame and the current one. And the video sequence is going to look like this. Okay, a lot of P frames dependent one upon the other. If one of them is going to get lost along the way due to packet loss, I can't decode any of the other frames. So I need to ask for a new iframe and start all over again. It's not a problem on a one-on-one call. It's fine with 5 or 10 people. If you move higher than that, that becomes again a problem. Okay? It's also not something that we want to do. What we can do is to use temporal scalability with WebRTC in VP8. And what we do the following. I've got this L0 frame, and then the next frame is going to be dependent on that one and on the keyframe. Then the next frame is going to be reliant only 2 frames back, following one on the previous 2 frames, and we're going to continue like that. Okay? Same result, almost the same video, but I can now throw out half of the frames. And instead of sending 30 frames per second, I can send 15 frames per second. I can also decode streams if L1 packets got lost along the way, which is also cool. Okay? It also gives our server a lot more choice. We said selective forwarding unit, an SFU. The selection that we have is, well, I can do 30 frames per second for a video. If I use simulcast, I can do 30 frames per second in 3 different layers, each one giving me a different type of equality for that video. Okay, but with temporal scalability, the SFU gets 3 more choices of doing the same quality layers, but at different frames per second, at lower frames per second. So let's say that I'm on a call and we have 20 people in the call, and I want to go and show them all in a gallery mode. I will lower the bit rates to mid or low, put them all in 15 frames per second from the server to the user that is viewing gallery mode. Another viewer at the same time is looking in presentation mode only at me. So the server is going to send him the high quality 30 FPS frame for me. Okay? So there are a lot of things here that you can do and optimize if you are using something like simulcast and temporal scalability in WebRTC, in the SFU, and if you know what you're doing. Okay, these are optimizations that need to happen in the application, that they cannot happen within the servers on their own, because you know best what the use case is like and what your requirements are. Let's move to audio. With audio, we have the same problem. 50 people, if 50 people are speaking or not, you still need to send 50 different media streams for the audio. In a normal case, one stream sends 50 packets per second for audio. That's a lot. Okay, what we can do is use adaptive P time and do something like this. I'm going to bunch and wait a bit between one packet to another for multiple frames. It adds latency, so I'm not sending every frame immediately when it's available on audio. But if I'm doing video and I'm going to wait for the audio for lip sync anyway, that's fine. And now I've got less packets to send. It's a nice approach. Okay, I wouldn't go and use that. Okay, what I would do instead is I'd use something like DTX, discontinuous transmission in Opus, which does the following. Instead of these 50 frames per second or 50 packets per second that are being sent, if I'm saying nothing, it will send almost nothing. It will send a packet every 400 milliseconds, saying, well, that person said nothing, don't worry, he's still there. Okay? So I don't need to mute and unmute people. I can just send DTX with 0 data on that channel. And that allows me, again, to scale up my session to bigger sizes. Okay? So there are different types of solutions out there. I try to give you some glimpses of what it means. One of the important things is that you need to test things and then test again. And you can also come and use test RTC for that. We've had a lot of companies come and use us in order to test scale or try to scale sessions to 50 or 100 or scale their servers and check sizing. Okay, thank you. And I'd like to open now the floor for any questions if you have any. You can just write in the chat or try to grab a mic. Which media server do you suggest? It all depends on the on the use case. If you are doing pure video conferencing, JIT is probably your best bet. Just because they have an almost complete solution. I like Janus and MediaSoup. Janus has a bigger ecosystem. MediaSoup is said by developers that are using it that it's got a better structure to it. Okay, so it's really there is no good answer. It depends on the use case. Sorry. Let's see. Yes, Nava. Let's see.
Hi. Yeah. Can you hear me okay?
Yep.
Great. So have you been able to kind of figure out the typical 49 people video problem per meeting with WebRTC? I know Google and Microsoft have been successful.
Yes. With different solutions. So Microsoft doesn't exactly use WebRTC. They use that on the browser. And there they do switching. So even if you do a call with 4 people and you're joining from a browser, you'll see only one, which is frustrating as hell. Google, on the other hand, did that on the browser directly. So you can only look at what Google is doing. So the things that we've seen them do is use a single peer connection. That's the first thing. They use DTX, discontinuous transmission, for the audio. They will reduce the bit rates on the SFU side for the lowest simulcast. They will switch to 15 frames per second, which is probably also something that Zoom is doing. And they would optimize Chrome while doing that because Chrome is theirs. Okay, this is why they are the first to get there. Others will get there as well, but it will take time. I've seen other companies getting to 36 at most today, which is also quite decent. It's not easy.
Yeah, I think we're getting kind of closer to that, like 30, and we're hitting compute issues and obviously signaling issues too. And so we're looking at peer optimizations, but we were just curious about even the decode. The CPUs that we have today would be actually able to support, that many number of videos simultaneously.
So there is one more thing that is really frustrating. There is no way to know directly what the CPU is like. So you can't say, no, this is an old machine, I'm not going to even try. So you need to find ways to understand what is, the CPU capabilities and then decide what is your target in terms of how many people you're showing. You can try to get there by understanding how many frames get decoded or how much time it takes to encode and decode a frame.
Got it. That's helpful. Thank you.
You're welcome. Rodrigo, to your question, SVC is not a real solution now yet. It's available only in VP9, and there is not many that are using it. So if I were you today, I would go for either 8264 or VP8. I like VP8 a bit better. And I would use that, at least today. Arseni, let's see, what is the maximum number of concurrent call participants that you successfully handled in one interaction? Well, I don't know. I didn't develop. Most of the time what I do is assist other companies to build stuff. And again, I've seen 36 active in a video call. You can get to 100 for audio only, or when you show only part of the participants, you can get to higher than that. You can take it even further. Also remember that in many of these calls, all of the videos are actually muted, so something like this. Ta-da, no video, okay? And in other cases, people will mute themselves. So you don't really need to handle so much in the ingress versus being able to broadcast to many. And once you go above, I guess, 100 or even 50, you need to start thinking of cascading or using multiple media servers for a single session. So you need to connect them one to the other. I hope that helped. Let's see. I see another one here before. Which recording approach do you suggest? GStreamer or FFmpeg? I've seen people use both, and I've seen people use both for real time. Whatever you like best. Okay. So Nava, just because there's, wait, let's see, Harsh, how close turning media servers should be located from, no compromise here. As close as possible to the user, okay? Really, go as close as you can. And if you can get closer, get a bit closer than that. Today, most of the services, most of the SIPA services will have around 10 data centers. Microsoft Teams, I think, has about 14 or 18. Chime also 14 or 18. So starting with 8 is a decent number, and then you can add more as you move along. The entrance of Azure and AWS, go to Blog Geek Me, look at the last 2 or 3 posts, it's written there. Is there a standard resource usage per interacting? No. Okay, it really depends. And yes, Agora has 250 data centers. Over. Nava, I'll give you another question.
Thank you. Yeah, a quick question. There's the other issue with WebRTC in general around scaling in the backend, where a lot of the compute seems to be going in decoding and encoding, or actually decrypting and encrypting because of the way RTC does encryption.
In the backend?
In the backend, yeah.
There is no decoding and encoding happening in the backend unless you're recording.
Encrypting and encrypting for every stream. So have you guys found like an efficient way to scale like a 4-core node to handle like a huge load of like meetings or number of active users?
So usually, in most cases, I don't get requests from companies that have a problem with that, with the time it takes to encode and to encrypt and decrypt. Sure. It seems like for the most part, people are fine with it. In many cases, the type of machines that I've seen are 8 or 16 core machines, like the C5 to X large. These are the starting point machines that I see most companies use for their SFUs. Once you go on these machines, you'll find out that the CPU isn't loaded. It's like, it's yawning half the day doing nothing. And you're paying for the network mostly.
Yeah, the reason I asked was more, Jitsi has these results that talk about 4-core nodes that are doing, I don't know, thousand people in a meeting or something like that. So I was just curious how they're able to achieve it, because you have this inherent problem of decrypting, re-encrypting every single connection.
So you need to ask them. I don't think that they're doing anything interesting there, to tell you the truth. There were discussions in Discuss WebRTC about that and how you can build it in a server and configure it in a way that it will use hardware and encryption and decryption, but I don't think they got into any specific solution. So I just don't know.
Got it. Thank you.
You're welcome. Okay. I see that there are no additional questions unless I'm missing something. Okay. So thank you for joining this session, and check us out, Blog Geek Me and Test RTC.